Okay, good day guys. Welcome to my channel. Today we have an Olympiad math question to be solved on the board. And you can see the question looks simple. So if you think it's simple, you can have help pause this video and try the question before coming back to watch. But don't forget to follow first. So we have 2 to the power of t equals 32. Find t. You're looking for t. You don't know what the value of t is. So the first thing that will come into your mind, because my thing is just indices, not ordinary indices, you do what? You try to make the base to be the same. But that's impossible because we have a variable on one side and y constant on one side. So it's impossible to what? Make the base to be the same. Another thing that will come into your mind is apply logarithm. But I'll tell you that will also fail you. So what if I tell you that you can use indices to solve this question without stress? It's possible. Watch. So solution. Every problem has its solution. So my first step is going to be, I'm going to try to make the unknowns to be on one side while the known ones, that is the two and the constants, to be on one side. So let's try to do that. How is that possible? That means you're going to move this t here. How can we do it? The question first. First thing first, try to remove this t. So how are you going to remove it? Multiply both sides by 1 over t so they can cancel each other as if you're dividing. So I would say multiply both powers by 1 over t. I have to do it to both sides. Both powers. I have to do it to both sides to balance the equation. So I have t to the power of what? T times 1 over t equals t to the power of 32 times 1 over t. So this can take care of each other. And I have what? 2 to the power of 1 left. Right? Equals what? T to the power of 32 all over t. This times this all over this. So next thing to do is to try to get rid of the 32 because I want it to be on what? On one side. How do I do that? Multiply times 1 over 32 so that it can cancel each other. So I would say multiply both powers by 1 all over 32. So I have this 2 to the power of 1 times 1, 1 all over 32 equals t to the power of 32 all over t times 1 all over 32. So this can take care of each other, right? And I can multiply this. So let's move to the next part of the board. I can have this as 2 to the power of 1 all over 32 equals t to the power of 1 all over t. 1 and 1. So 1 times 1, t times 1, I have this. But now you can see that my right hand side has t and t, so that one side now, I've done what I wish to. But next step now is to try to make both sides to be the same, like to be equivalent, so that I can compare the both sides of the equation. How do I do that? Now you watch. You see that if I can raise 2 to the power of 8 and I multiply this by 8, I would have the same value. If you notice. Now let's do that. So can I express this as 2 to the power of 8 all over 8, 1 all over 32. This does not mean anything. Remember, it doesn't mean anything. 8 cancel 8 is still 1 time. 1 times is the same thing, right? So equals t to the power of 1 over t. The strategy is to make both this and this to be the same so that I can equate it. So what do? I can express this as 2 to the power of 8 bracket 1 all over 8 times 1 all over 32. I see where we're going to now. I bring the 8 inside, law of indices. So I would have this as what? 2 to the power of 8 is what? 256. 1 times 1, 1. 8 times 32 gives you what? 256 also. If you notice, equals what? T to the power of 1 over t. So definitely it's obvious now that we can compare the both sides of the equation. T, 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 T. I see now. So definitely T equals what? 256 without stress. Thank you for your time. Follow for more.